All right, so today, function notation, section 1.7. If you can do problem number 3 on the warm-up, today is going to be very similar. All right, function notation is just really going to be evaluating some different types of functions. Okay, so again, if you can evaluate like we did on number 3 in the warm-up, you can do today's lesson. All right, and hopefully after a little bit, you'll start seeing, yeah, we did that in Algebra 1. It's a little bit of a review. All right, vocabulary here. Function notation is what we're going to be focusing on today. It talks about x is the independent variable. Okay, x is the independent variable. And y is the dependent variable. Then the function notation for y is f of x. All right, whenever we do something like this, it seems like students always get confused with what f of x is. F of x just stands for the function of a graph. Really, f of x stands for y. Okay, so don't get any confused of what is f of x. F of x is just going to be what our output is. F is the function, essentially, and it really just stands for y. Okay, the key here is f of x is red. Again, if you see here, f parentheses x, that's red f of x. We also use a lot of times g of x. You might see in your book g of x. You might see h of x. Very rarely, but sometimes you might see t of x. Those are usually the ones that pop up the most. But again, it takes an equation like this, so y equals 2x, and it says my function notation is f of x equals 2x. So you notice the y and the f of x essentially are just switchable there. It's just the same thing. Independent variable, just like you think about science, independent variable is what you input in. Okay, we're going to be doing a lot of inputting. We're going to be inputting a number, inputting something into the function, and then with that, we're going to get a dependent variable, which is our output of the function. So we're going to throw a number in, and we're going to get a number out. All right, input, output. And if you look, our input is our x value, or our independent variable is our x, and then our output or dependent variable is our y. Okay, and a lot of times dependent variable could also stand for like our f of x part. That's what we're going to be getting back out. Okay, that's what we're going to be solving for today. So we're going to take numbers, we're going to put it in, and we're going to take numbers back out. Okay, it's going to be like a function generator. Here's what we're doing. Reach to Ryan Jarrett? Gotcha. All right, so again, function notation here. Red f of x equals 2x minus 3 here. So here's my function. Now it says I'm going to evaluate for 3 functions here. I have f of 0, f of 1/2, f of negative 2. Essentially, each one of those, when you evaluate for 3 functions, you get 3 answers back out. Okay, I'm going to go through how you do the first one here. So if I evaluate for f of 0, essentially what I'm doing is I'm taking the 0 and I'm going to replace it in x. So here's my function. And I take each one of my x values and I replace it with 0 now. I'm inputting 0 into the x values. Well, 0 squared gets me 0. 0 times 2 is still 0. Minus 0, still 0. Plus 1. I get my output of 1. Okay? Again, all it is, you're inputting it, and then you're really just going to evaluate it and get an output. Okay, same thing can be done for f of 1/2. You input your 1/2 for all your x values, simplify it down, and you get an output. I get a second answer. Do the same thing for negative 2. Input negative 2 for my x values. Simplify it out, solve it out, and I get an output. Okay, that function there would have 3 answers, 1, 1, and 11. Okay, a lot of your assignments today will ask you to evaluate the function for 3 different values. That's really what it's going to be, just 3 different answers, just like that. All right, so let's look at what this actually looks like with the problem. So number 1, I want to evaluate the following functions for f of 0, f of negative 1, and f of 1/2. I'm going to start off with f of 0. So f of 0 means I'm going to plug 0 in for my x values. Okay, so I have 4 parentheses 0 squared minus 2. Again, I just took my 0, put it into my x values. I'm going to get an output. Well, what's 0 squared going to give me, Shane?
0.
Times 4? Minus 2? Boom. My output is negative 2. Plugging a number in, you're getting a number back out. Input, output. Let's do f of negative 1 now. So I have f of negative 1 equals 4 parentheses negative 1 squared minus 2. Again, for every one I'm doing, I'm just evaluating it for the function it gives me at the top. Well, what's negative 1 squared, Garrett?
1.
Times 4?
4.
Minus 2? My output is 2. Plugging a number in, getting a number back out. Now, fractions can maybe be a little bit more difficult, but not really. So I have f of 1/2 equals 4 parentheses 1/2 squared minus 2. Okay, 1/2 squared. What is 1/2 squared, Jack?
1.
So 1/2 times 1/2 is 1/4. So I get 4 times 1/4 minus 2. Well, 4 times 1/4 gets me just what, John? 1 minus 2 is? Negative 1. So my answers there would be negative 2, 2, and negative 1. Again, is it just like evaluating like we did in the warm-up? Yeah, it is. You're plugging a number in, you get a number back out. All right, let's try the next one here. I'm going to evaluate for the same functions. I have f of 0 equals negative 2 times 0 plus 10. Negative 2 times 0 is what, Reagan?
0.
Plus 10. My output is 10 there. Nice job. F of negative 1 now. So same function. F of negative 1, negative 2 times negative 1 plus 10. Negative 2 times negative 1 is what, Mark? Negative 2 times negative 1? 2 plus 10 gets me?
12.
My output is 12. Nice job. And the last one, f of 1/2 equals negative 2 times 1/2 plus 10. Negative 2 times 1/2 is what, Sage? What's half of negative 2? So negative 1 plus 10 is then what, Sage? Did I hear you say it right? 9? There you go. 9 is correct. Again, you're plugging in three different function inputs, and you're going to get 3 different outputs back out. Try these 2. All right, let's look at number 3. If I were to evaluate for f of 0, what do I get, Bailey? 0. Nice job. If I evaluate for f of 2, what do I get, Andy? You get what?
16.
Thank you. If I evaluate for f of negative 3, what do I get there, Ethan?
9.
Negative 9?
Yeah.
That is correct. Nice job. The key there on that negative 3, you have to make sure on that first part you put negative 3 in parentheses squared. That makes a difference because that means negative 3 times negative 3, which then gets us positive 9, plus then the negative 18, which is where we get negative 9. Nice work. Number 4, f of 0. Sophie, what do I get if I plug in f of 0? So 2 times 0 is 0. Minus 4 is going to get me. Nice job. Negative 4. F of 2 is what, Shane?
0.
Nice work. And f of negative 3 gets me what, Mark?
Negative 10.
Negative 10. Good work. Again, that's evaluating functions. Very similar to just evaluating kind of equations, really. Next part here now, we're going to talk about, well, you can graph functions, okay? If you look at the top there, plot the ordered pairs on a coordinate plane to graph a function. This is kind of an example of like a mapping diagram. We looked at those yesterday. You know, it shows 3 is going to 2. So 3 is my input, 2 is my output. 4 is going to 5, 4 is the input, 5 is my output. 5 goes to 9, and 6 goes to 14. And those are just plotted on those points right there. Okay? So if I'm given points like that, I plot just those points. If I'm given an actual function, like down here it says f of x equals negative 2x plus 3. Well, I can evaluate that for different values of x. Now, essentially, you can pick values of x. Does anybody know why those 5 are the most common that you would probably pick? Or why those 5 would be the best 5 to pick? If you look at those 5, what do you see as some commonalities and some differences? What do you notice? What do you notice about what's something common about them? They're all what, Phil? They're all like low numbers, right? Do you agree it's easy to multiply by 1 and negative 1 and zeros? So those are all easy numbers to compute. Difference is hey, they have some negatives, positives, and a 0. That makes it kind of a good value, a good range of values that I can see both sides of the graph. So what happens is I take my negative 2 and I plug it in for my x values, and I get an output. Okay, so just like we were doing, you put in a value in, you get an output. Now the difference is it actually wants me to graph that. So it will graph negative 2, 7. Well, that's that point there. Negative 1, 5. Well, that's my input output there. 0, 3, 1, 1, and 2, negative 1. But now because it gave me a whole function, I now connect them with a line. I'm trying to match it up there. I now connect it with a line because it's the whole function. Whereas the top one was just specific points, I marked just the points. If it gives me a whole function, as in f of x or g of x, I can connect them all with a line. Alright, so let's look at the next one. Number 5. I want to make a table of values and graph y equals 2x plus 1. So table of values here. I have my x and I have my y. What are the best values of x that I'm going to choose, Garrett? What are the values that we had in the last one?
Negative 2, negative 1, 0, 1.
Awesome. And then every one of those I'm going to plug into the function 2x plus 1. So if I plug negative 2 in there, so negative 2 times negative 2 plus 1. Negative 2 times negative 2 is what, Jack?
4.
Negative 4 plus 1 gets me? Jack?
No, 5.
Negative 4 plus 1?
Negative 3.
Negative 3. So I put my input in, I get an output. And I can plot that point. So negative 2, negative 3, right there. Next, I plug in negative 1. So 2, negative 1, plus 1. 2 times negative 1 is what, Reagan? Plus 1? Nice job. And I can plot that point. Negative 1, negative 1. Do the same thing with 0. If I plug in 0, what do I get for an output, Sean? 1. So 0, 1. What? You kind of know it's a line, right? That's kind of true. If I plug in 1, what's my next value, John? 3. And the last one, if I plug in 2, what's my last value, Shane? 5. And the last thing, because we're talking about a whole function there, I would connect them all with a line, just like that. All right, try number 6 here. Same idea, make a table. Evaluate it for the function x squared minus 3. All right, if you look on the board, the function is made for us there. Again, use the same values, negative 2, negative 1, 0, 1, 2. Now, does that mean you only have to use those values? No. You can pick other values. You can use negative 3. You can use negative 5. You can use positive 5 if you wanted to. Those sometimes are just the easiest values because a lot of times they're smallest, closest to 0. When you plug it in there, does anybody know what type of graph I make here? If I were to connect these, I kind of get a graph that looks something similar to this. Does anybody know what that graph is called? What's it kind of look like? A U. Actually looks like almost like a U more. My bottom's a little messed up. That's a parabola. After tomorrow, you'll hopefully learn a little bit more about those. But that'd be a parabola graph, which goes with anything with a squared term, essentially. Okay? Now, if I were to ask you the question, you'll have problems like this. If I said, hey, I want you to evaluate this for f of 0. So looking at that graph, okay, looking at my graph, f of 0 equals what value? So if I look where my x value is 0, what is my y value going to be, Sean? -3, yeah. Okay, you have some problems like that in your assignment today. Well, it's going to give you just a graph. Really what that's asking you to look for is, hey, where is x equals 0? And you find the point on that graph. Okay? You know, if we had the function over here, it's kind of easier to tell. But if you had just the graph, you can still identify where the functions are at. I think we got a pretty good hang of this. Here is your assignment.